Do you have it?
I'm sorry, what?
Do you have the meaning?
Oh, sorry. Yeah, it is 799.
Okay.
744.
All right.
005.
Okay.
I forgot you weren't in the meeting already.
Yeah, I'm on the slow computer today, so
Okay.
I'm trying to get it started up. Thinking the computer I usually use, it broke, which is excellent.
Really?
The keyboard's no longer responding to the monitor.
Keyboard's not responding to the monitor.
Yeah, to the screen, like you type it.
Uh-huh.
It comes up.
Is it a keyboard that's plugged in to the back?
Nope, it's attached. So. Yep.
Wow. Well, that's kind of a bummer.
Oh, it's not working.
It says waiting for name, so it's
I don't know.
it's picked
Maybe
you up.
Put in an email address? Is that what that is?
The first time when you log in, there it is. There it says David has arrived.
Alright, well, let's see. Okay.
Okay. Can you see everything now?
Yeah.
Okay. Cool.
Got your screen. You know what? Alright. Yeah, so today in class we started exponential growth and decay.
Okay.
So I have some of those problems
Okay.
to do. Or maybe a few of them. And then some SAT focus, or depending on how the problem is, I guess.
Okay.
Alright, so, yeah, we got our test back.
Uh-huh.
B. It brought my grade down to a B.
Really?
Yeah.
Oh, okay.
But, I mean, better than I was doing in honors.
Yeah. Yeah.
Yeah, but, what else? I don't know. I don't have any more math related. I'm having trouble with my thoughts. Sorry, I'm having trouble finding the page called myself.
Sorry.
Okay. So, first few problems are multiple choice, so do that. Okay. I'm just going to skip the ones I don't think are necessary.
Okay.
Okay, so, I just want to do the word problem one.
Okay.
Because I can graph them and stuff, just trying.
Okay.
I'm really setting them up much bad either. Okay, so the first one says, write an exponential decay model that describes the situation. And the problem says you buy a stereo system for $780. Okay. And then each year T, the value V of the stereo system decreases by 5.
Okay. That's it? That's all the information they give you?
Yeah, and it just wants you to draw, or not draw,
Well, so the amount at any point in time is equal to the initial amount times e to the minus 0.95t. Now, hold on a moment. Let me think about that for a second. Is this your general formula?
The general formula we have is y is equal to a, which is the principal amount.
Mm-hmm.
Uh-huh. Times 1 minus the decay rate.
Okay. All right.
And to the power of t years.
Right. Okay. This is continuous growth there. So amount equals the starting amount times 1 minus 5%, 0.95 to the t.
Yes.
So this would be A equals 780 times 0.95 to the t. And clearly, when t is 0, this becomes 1, and it's worth 780. And when t is 1, it's going to be worth 95% of 780, which you want. And then when t is 2, so forth and so on.
Alright, I don't know, I just want to do a lot of graphing, which we're allowed to do the graphing on the calculator, so.
They want you to do the graphing on the calculator?
No, it's just the problems are asking for graphing, and the graphing we do is calculator graphing, and then to find the specific point asked for that, you just trace the point. So it's easy. I don't have.
Oh, I see. In other words, if they want to know how long it takes to get down to $400, you graph it and solve for t that way?
Yeah.
So you would say, so you would set that as one function and set this as another function, and where they intersect is the answer?
Yeah.
Okay.
That's how we solve it. So all of, I mean, I have like.
Have you had logs yet? You haven't, have you?
We haven't. I don't know if we're going to do that.
Okay.
In honors.
This would be a typical log problem. Whenever you have an equation to solve where the variable's in the exponent, it's a wonderful log solution. I take the log of both sides, which allows me to take this exponent and put it back down on the line, and then I can solve it. But the way they have you solving it is fine. As long as you know how to do it, we don't need to go through that.
Alright, yeah, I mean, it's just, I'm trying to see if there's anything I should do, but it's, I don't know, it's all graphing, and it's easy graphing. So.
Yeah, as long as you know how to. Go ahead.
Thursday,
What's that?
and during that, I'm going to ask my teacher for a little, like, she usually gives out, like, this little syllabus looking thing. Where it has all the subjects we're going to cover.
Okay.
Get that from her, and that way I'll have that so I can work ahead in class, hopefully a little bit.
Yeah, that would be helpful. That would definitely be helpful.
Then I'm going to talk to her about what else I should do to help get ready for the ACT and all that.
Okay. Well, so you want to cover some ACT for the rest of the half hour?
Yeah, I mean, I was kind of hoping my homework would be a little more, have them, like, tell whether it's exponential growth or decay, but that's just, is the number bigger or greater than 1? Yeah,
if it's growth, it's 1 plus the rate. If it's decay, it's 1 minus the rate.
Yeah.
Pretty much. Let's see. I created a file last time to mark where we had gotten to. We got to question 13. So let's see. Too far. Yeah. Can you read that okay?
Yep, everything's good. Okay. Yeah, count the number of weeks. Oh, so it's just averaging? Alright.
So Yeah, you can just tell me how you're going to do it if you like.
Okay, well, I was going to add them all up and then divide them by 5.
Okay, that's going to give you the right answer. So let's go on. Okay.
Alright. X minus 3 and x plus 6 are solutions. Oh, that's cool. Would it be the last one?
No,
No?
it would be A. Notice that to solve A, we would set this equal to 0, and then x would be equal to 6. And we would set this equal to 0, and then x would be equal to minus 3. So it's good to realize that when you solve a quadratic, you get it into two linear factors, which is what these answers are. Okay, and then the solution is always the opposite sign of that number. In other words, if x minus 6 is equal to 0, then x is equal to 6.
Okay.
Okay?
So just like with these factors?
Yeah, it's exactly. In other words, if somebody came up to you and said, solve equation A, well, you know that if one thing times another thing is equal to 0, then we're going to set each of those things equal to 0, because one of them has to be 0. You can't multiply two numbers together and get 0 unless one of them is 0. That's why we solve quadratics in the way we do. The reason we set it all equal to 0. This one looks a little blurry here. Hope you can read that. Let me bring up my other page here. Right. So we have 7 minus 2x minus 10. What is that equal to?
That would be equal to, we have negative 2x plus 20. Or would you would distribute first, right?
Uh-huh.
Yeah.
So we have 7 minus 2x plus 20. And now simplify.
And then you get
Well, yeah.
27, right? 27 plus minus 2x.
Yeah.
Divided by 2.
No. So what's the answer?
They don't even want you to do that.
No, they just want the expression after you've simplified it. We're not really solving an equation here. So it's h.
Yeah.
Okay.
And x would be equal to.
How are you going to solve this? I'm curious.
Well, you could put down 0.6x equals 9, right?
Okay, that's pretty good. They're not everybody would be able to formulate that. Okay.
Yeah, and then you divide it by 0.6.
Okay, that would be correct, and that gives you the correct answer. Let's say you couldn't formulate it. How would you solve?
Guess and check.
Yes, this is the perfect one for that. And in fact, when you start looking at the answers, you immediately know what the answer is.
Yeah.
Because they don't put anything close to it. It clearly isn't going to be 1,500. And it clearly is going to be a number bigger than 90. So none of these three work, and this one doesn't work. That's got to be it. 60% of 150? 90. So even if you couldn't set it up, but this one was easy enough to set up that it's probably easier to solve by algebraically setting it up and just solving it, I guess. I don't know. I'm a huge fan of guess and check. I really am.
Okay, so you first step would be this is like combination and stuff, right? That's how they want you to do this?
Well, this is a word problem. What's the first step you want to do on all word problems?
Read it and determine what it is.
Define your variables.
Oh yeah, that's
Define your variables. The moment you define your variables, the problem almost solves itself. So let's let D be the cost of a drink. And as long as we're putting down variables, let's let P be the cost of a popcorn. So now what's the first equation I can write?
D plus P equals 5/10.
And what's the next equation I can write?
2P 1D equals 835.
And that's the only way I know of. Now what would be the quickest way to solve for D?
To subtract or solve for D.
Well, they want the cost of a drink. We could solve for P a little bit quicker. In other words, we could solve for P by subtracting equation 1 from equation 2 immediately. Right?
Yeah.
In fact, I'm inclined to do that. Notice how much easier it is to solve for P than it is to solve for D. Because I can subtract, if this is equation 1 and this is equation 2, if I take equation 2 and subtract equation 1, I get P equals $3.25. One step. Okay? So P equals $3.25. And now it's relatively easy to solve for D. I just go back to equation 1. What number when added to this equals 510? Well, that's got to be $1.85.
Okay.
Okay? Now, let's look at that for a moment. Because they wanted to solve for a drink, they don't care what popcorn costs. Usually, I would be inclined to solve for the D as the first variable. I would want to solve for the D as the first variable. But in order to solve for the D here, you kind of need to multiply this by -2 or 2 and eliminate the P. So it's a much harder process to solve for the D. I'm still going to get $1.85, but it's actually easier to solve for P as your first variable and then go back and solve for D, I think. I think that there's less math.
Yeah.
Okay.
Alright, so either way though, it doesn't...
Yeah, either way you come up with $1.85. That's a relatively hard ACT problem. There are not too many problems where you have to formulate 2 equations and solve for a variable.
Yeah. Alright, okay. Standing in line, favorite 2 ranks. Okay.
Do you have your calculator?
Yeah.
Okay.
Alright, so you would multiply by, you wouldn't want to add them first, right? You'd want to take the...
No, you do want to add them first, because notice the problem is not what the total cost is. The problem is you have $21 bills. What's the exact change part going to be? So we want to come up with a total price that you're going to have to pay for these two lamps.
Alright.
So the first step, let's multiply that number by 2.
So 17.98.
Now what?
Multiply them by 0.07.
Well, why don't we just multiply it by 1.07? Remember, this was the same issue you asked about the other night. Can you, if something is discounted by 20%, can you just multiply it by 80%? And the answer was yes. Well, if something is increased by 7%, then you can just multiply it by 1.07.
Oh, okay.
I mean, you could multiply it by 0.07 and then add that number to 1798. But since you're doing it on a calculator, it's better to just do it in one step. So what do you get when you multiply that?
You get 19.24 after you round.
So what is the answer to the problem?
The answer would be the 17 point would be 1.25. No, wait.
It's a little tricky. They're trying to trick you.
24 cents.
Good, good, good. Because notice they have the 76 cents answer on there. If you didn't read this real carefully, you might think that how much change would you get back from your $20 bills? Well, you'd get 76 cents in change if you gave them $20. But that's not what they're asking. They're asking if you wanted to pay with exact change, you would need 24 cents in your pocket. Yes, very. Okay. R cubed equals 343. How do you get 3R?
Well, I would take the root of 343 and then multiply it by 3.
Okay, good. Yep.
I don't know if there's an easier way to do that.
No?
21.
Good. So the cube root of 343 is 7. Right?
Yep.
And then 3 times 7 is 21. Yeah. Good. Okay. Put those in proper numerical order. We have pi, we have 7/3, and we have 9/2. What's the best way to put those in order?
Put them all into decimals.
Okay. So this is 3.14. That may be all we need. What about 7/3 is what?
2.3.
And 9/2 is 4.5, so now it becomes easy.
Yeah. So you would want the 7/3 and then the pi to be.
Yeah. That's a good one, 22.
Right,
What number can you add to the numerator and the denominator to turn 9/13 into 3/4?
Is there an algebraic way to do this?
There is, and I'll give it to you in a moment. But before we do it algebraically, the algebraic solution is a little tricky if you don't know how to set it up, so let's do it another way.
I would guess and check, but...
Well, okay. First of all, is 9/13 smaller or larger than 3/4?
I'm going to say smaller.
Yeah, the numerator is 3 times larger, but the denominator is more than 3 times larger. So this is going to be a little bit smaller than this. let's just try one of the whole numbers. If we're going to guess and check, this brings up a good point. If we're going to guess and check, are we going to be 100% sure whether we need to increase or decrease? I wouldn't be. Not without a great deal of analysis. I would not be 100% sure. So I might have to check all 5 of these. In other words, if I check this number right here and it doesn't equal 3/4, then I'm not really going to know whether I need a bigger number or a smaller number. So there's lots of math potentially that I have to do. So let's ignore these 2 fractional values for the moment, and let's just see what these whole numbers. It's relatively easy to figure out what this would be. When I use 3, what do I get?
You would get 27 over 13 times 3.
Hold on. We're going to add the numerator and the denominator.
Oh, okay. Get 11 over 16.
Get 12. If we add 3 to 9,
Sorry.
we get 12 over 16. Is that the same as 3/4?
Yeah.
Bingo. We're done. But let's look at the algebraic way. It's a word problem. What's the first step?
Identify the variable.
X is the number. So now what can I write?
You can write 1. Okay. Well, you can write 9 plus x over 13 plus x is equal to 3. 4.
Now, notice how you couldn't do that until you did step 1. Once you did step 1, you knew exactly how to do it. That's how important this step is for some reason. I don't know. It's almost like a mystery. But most word problems, the moment you define the variable and spell out what it is, the problem just kind of unfolds in front of your eyes. Now, not that this is that easy to solve, but it's not that hard. Just cross-multiply and solve. Okay, so x would solve for 3 there. All right. Let's look at one more here. It's the slope of the line between these 2 points.
Y2 minus Y1, right?
The rise over the run. So it's the change in the rise, the change in the y. In other words, I tend to think of slope as being delta y over delta x, which is the same thing as what you just said. Y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. But it's really the change in the rise over the change in the run.
So, I think it's 3 over 11, isn't it? No, why would it be 3 over 11? Yeah.
What's the change in the y?
Well, I guess it was negative 3 if you put 7 first.
No, actually not. In other words, minus 7 minus 4 is minus 11.
All right.
And then 2 minus 5 is minus 3. So 11/3 is the answer. But notice that there's actually an easier way to do it, where we don't have to have a hard negative number problem like that. And that is to reverse. Instead of taking y2 minus y1, let's take y1 minus y2, and we'll take x1 minus x2. And that way, it allows us to do 4 minus a minus 7 all over 5 minus 2, which again gives us 11 over 3, but the math is easier. I guess, don't you agree that taking 4 minus a minus 7 is easier than taking minus 7 minus 4?
Yeah, I think the more positive numbers, the better.
I agree, totally. So just remember that you can always go either way. Just be consistent. You can't go either way and mix it up. You can't do y sub 1 minus y sub 2 and an x sub 2 minus x sub 1. You'll get the wrong sign on your slope. But as long as you switch both of them, it gives you the same sign.
Alright.
Okay? All right. This is what, Wednesday? So I'll talk to you next Monday.
Awesome. Thank you.
All right, Sarah. Bye-bye.